We know more about space than we do about the ocean, which is true.
And I took a big breath, and I went down, and I saw, like right in front of me, this huge eyeball.
Those underwater listening devices were most likely so that they could hear UFOs moving around.
Beneath the tranquil beauty of the Pacific Northwest lies a ticking geological time bomb, Mount St. Helens. But now, an even more chilling discovery threatens to rewrite the story of this volatile region. The Pacific Northwest is a land of breathtaking mountains, ancient forests, and a rugged coastline that draws millions each year. Yet beneath its serene exterior lies one of the most active geological regions on Earth. Mount St. Helens, infamous for its catastrophic 1980 eruption, has long captured the attention of scientists and adventurers alike. But recent findings by the US Geological Survey, USGS, have unveiled a terrifying secret, a mysterious leak on the ocean floor near the volcano. What does this leak mean for the future of the Pacific Northwest? And could it trigger a chain reaction of catastrophic events? Mount St. Helens has always been a geological enigma. Nestled along the Cascadia Subduction Zone, where tectonic plates collide, it's part of a volatile system prone to earthquakes and volcanic activity. In recent years, advanced monitoring tools have revealed seismic rumblings and signs of awakening beneath the mountain. But it's the nearby ocean floor that has shocked the scientific community. During a routine geological survey, scientists detected a strange anomaly: warm fluid seeping from the seabed at an alarming rate. Initially thought to be a typical hydrothermal vent, further investigation revealed something far more sinister. This leak was no ordinary outflow. It was releasing methane, carbon dioxide, and chemical compounds directly tied to magma reservoirs deep beneath Mount St. Helens. The discovery set off alarm bells. These types of leaks often act as pressure valves, signaling instability within the Earth's crust. If the magma chambers feeding Mount St. Helens are under extreme pressure, the consequences could be catastrophic, potentially leading to seismic events or even a volcanic eruption. The leak's location adds another layer of danger. It sits disturbingly close to the Cascadia Subduction Zone, a region capable of unleashing megathrust earthquakes with magnitudes of 9.0 or higher. Such an earthquake could trigger massive tsunamis, devastate coastal cities, and disrupt life across the Pacific Northwest. To complicate matters, the fluid escaping from the leak is laced with methane, a greenhouse gas over 80 times more potent than carbon dioxide in trapping heat. While the current emissions are small, the risk of larger methane releases looms large. Beneath the ocean floor lie vast deposits of methane hydrates, ice-like structures that trap methane gas. Even minor temperature changes could destabilize these deposits, unleashing a catastrophic feedback loop of warming and gas release. Adding to the mystery, seismic tremors, known as harmonic tremors, have been detected near the leak. These tremors, often linked to magma movement, suggest that the Earth's crust in this area is far more dynamic than previously thought. Some experts speculate that the leak could be part of a deeper, more complex geological system, potentially tied to ancient, dormant structures beneath the Pacific Northwest. The worst-case scenario surrounding an underwater volcanic eruption near the Cascadia Fault leak is nothing short of catastrophic. Imagine the sheer power unleashed if volcanic activity were to occur in this already vulnerable region. Such an eruption would instantly displace massive volumes of water, unleashing tsunamis that could race across the Pacific Ocean at speeds up to 500 miles per hour. These towering waves, capable of reaching coastal cities like Seattle, Portland, and even further, would arrive in mere hours, leaving minimal time for evacuation and disaster preparedness. The impact on these urban centers would be devastating, with coastal infrastructures, ports, and residential areas swept away in the blink of an eye. The primary wave of destruction would be immediate and highly visible. Entire neighborhoods inundated, buildings reduced to rubble, and thousands of lives at risk. The force of a tsunami isn't just in its height, it's in its ability to flood miles inland, destroying everything in its path. Seattle and Portland, being major population and economic hubs, would face catastrophic losses. Skyscrapers could crumble under the sheer pressure of water and debris, while key infrastructure such as highways, bridges, and power grids would be rendered useless. The ports, which serve as vital arteries for trade and commerce, would be paralyzed, creating a ripple effect on the economy that could last for years. But the disaster wouldn't stop there. A volcanic eruption near the fault would also disrupt marine ecosystems on an unimaginable scale. The sudden displacement of water would cause shock waves that could devastate delicate habitats. Coral reefs, already vulnerable due to climate change, would face further destruction. Deep-sea creatures adapted to stable conditions would be subjected to violent changes in temperature and pressure, likely leading to mass die-offs. Entire fisheries could collapse, depriving coastal communities of their livelihoods and disrupting global seafood supplies. The environmental consequences would extend beyond the ocean. Widespread flooding triggered by tsunamis would contaminate freshwater supplies with saltwater, sewage, and industrial chemicals, making clean drinking water scarce. Agricultural lands near the coast would be rendered unusable, compounding food shortages in affected areas. The inundation of urban areas would lead to the release of toxic substances from factories, oil refineries, and hazardous waste sites, causing long-term environmental damage that could take decades to mitigate. From an economic standpoint, the damages would be astronomical. Early estimates for similar scenarios suggest losses could easily climb into the tens of billions, if not more. Insurance claims would skyrocket, and rebuilding efforts would place a massive strain on local and federal governments. The economic toll would not only impact the affected regions, but also ripple through national and global markets, given the strategic importance of cities like Seattle and Portland in trade and technology. Beyond the immediate physical and economic devastation, the psychological impact on survivors and communities would be profound. Entire populations would face displacement, leading to a refugee crisis in regions unprepared to handle such an influx. The loss of loved ones, homes, and livelihoods would leave lasting scars, with mental health issues like PTSD, anxiety, and depression becoming widespread. Efforts to recover from such an event would be monumental, requiring international aid, collaboration, and innovative strategies to rebuild. Yet even with the best recovery plans, the scars left by such a disaster would be indelible. Coastal cities would be forever changed, both physically and culturally, as they grapple with the consequences of living on the edge of one of the world's most volatile geological zones. As scientists race to uncover the truth about this mysterious ocean floor leak, one thing is certain: the Pacific Northwest is sitting on a powder keg. This discovery is a stark reminder of our planet's raw power and unpredictability. While we cannot control the forces of nature, we can prepare and adapt. Will this leak serve as a wake-up call, driving humanity to action, or will it be a harbinger of disasters yet to come? Only time will tell. Stay tuned as we continue to explore the mysteries of Earth's volatile systems, because understanding them might just be the key to our survival. If you're fascinated by the mysteries of our planet and the forces shaping its future, don't forget to like, subscribe, and hit the bell icon. Join us as we dive deeper into Earth's most captivating and terrifying secrets. See you in the next video.